All right. Greetings, fellow grade 12s. It is your favorite tutor, Mr. Shajwayo, and welcome back to basics, right? So we are still looking at some of the things that you might have done in the previous grade, especially as far as statistics it is concerned, right? We are trying to understand in terms of how do we go about in solving these questions, right? So now I want us to look at this particular question here. Now they are saying here you are having what? They are saying the distance in centimeters of best attempt of 11 long jumping athletes during an athletic event are given below, right? So basically this is the data. And then now they want us to calculate what is going to be the mean distance of these athletics best attempt, right? So now what is it that we know basically now for this one? We know that there are two ways in which we are going to do this thing, right? Now, for an example, there are two ways in terms of you can do mean by simply using the calculator method or by using the manual method, right? So personally, I prefer the calculator method, right? So I think that's what we are going to do in this particular case. But the manual method basically would be that you would say your mean, right? The mean, remember, mean is given by X bar, will be equals to all the total values here, which means you add all of them here, 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 right? Then you divide by the what? You divide by 11. Remember, all of them, they are 11. Then you divide by 11, right? So which means now, for example, if you add all of them, they are going to give you 5, 4, 7, 8. This divided by what? By 11 out again, right? And then this will be given by 498 altogether, right? And if you, let's say you are doing a calculator method, then you're going to go to your calculator. And remember, it must be occasional calculator. So you press the mode button, then it's going to give you options up until 5. You press option 2, which is stats. Then after pressing option 2, you press option 1, which is VAR, right? And then you plug all the data, right? Which is 289, which is 287, which is the first one. Then which is 328, which is the second one, which is your 374, which is the third one. Then you are having 486, the fourth one. You're having 492, the fifth one. You're having 501. And then you are having 522 equals to, then you are having 583, then you are having also 601, then you are having 619, then you are having also 685, right? And then that will be the 11th data, right? And then you press your, once you've inserted all the data, then you press your HC button. You'll realize that in your calculator, there will be a zero. And if you are looking properly there, you'll see stats, right? So which means you can now say shift. You press the shift button, then you press one, right? And then I think above the button one, you can see stats there. And then you can find out there your what you can find out here. For an example, you can go to 4 and you can find out what is your mean, right? And I think for your mean, if you are checking there, it's this button that has an X bar, which is option number 2. Then you'll still find the same mean which we found there, which was 498, right? So whether you do it manually or the calculator method, the results are still the same, right? So, but I strongly recommend that we go through the calculators because it's much more quicker, and especially now, and you are in a position to actually get accurate answers, right? Okay. Now let's look at your 1.2. Now the 1.2 requires you to do your standard deviation, right? So your standard deviation is basically this, right? And I think if you've already inserted your data in your calculator, now you can press again AC, then you say shift 1, you go to 4, which is VAR, and then you're going to look at option 3. That option 3 there is going to give you what? It's going to give you your standard deviation, right? And what is that you're going to get here? This is 119, comma 4. I think this is 119,47 altogether, right? So basically that is going to be a standard deviation here. altogether, right? So basically, that's going to be that one. And now, if you are looking at 1.3, 1.3, they are saying determine how many distant lies outside, right? Lies outside one standard deviation, right? From the mean, right? So inside here, what is it that you're going to do now? From here, this type of question, whenever we are given here, you are having two things here, right? So to understand the data that lies outside one standard deviation, which means you must have what? You must have your mean. This is mean. The formula, it's mean, subtract your what? Subtract your standard deviation. And then the other one is going to be your mean plus your what? Plus your standard deviation, isn't it, right? And now from here, what else then now are you going to have here? Which means now from here, what is that you're going to have? Now you're going to say, what was the mean there? The mean, it is given by 498. Subtract what? 119.47. And then you are also having what? You are also having your 498 plus 119.47, right? How to get, right? So basically that's that. And then if you are calculating this, this is 37, it's 308, 378.53 if I'm not mistaken. And then this other data, this side, it is 617.47 if I'm not mistaken, right? So now you are going to look at the data from here that is going to lie outside, right? So which means when we are saying outside, which means it can be what? It can be the data after 617, or the data that is going to be before 378. And now if you are checking here, for an example, if you are checking here, what is it then that you are going to be having here? If let's say we are making up our space here, what is going to be that one, right? So if you can see, you're having 289, which is, I think it's less than 378. You are having what? You are having 328, which is less than that. And then you are having I think this is 374, which is still less than 378, right? However, now, if you can see now, this 486 lies within that particular date, right? So which means these ones, you're not going to include them, right? It lies within that data. However, what you are not going to include, now, if you're looking at 619 now, 619 now, it lies outside, right? Remember, it can be before, and then it can also be what? This is also can be after, right? So which means this is going to what? 619 and also 685 lies after, which means you're having how many? You are having 5 distances, right? Once again, that lies outside one standard deviation. Once again, right? So basically that is going to be that one as far as your question 2, or rather 1.3 is concerned, right? Now, I want us to look at now what is going to be our 1.4. What is it that really we are required to do in 1.4? Now, if you are looking from here, we're just continuing, right? So here they are saying the officials that are measuring the distance of the long jump athletes mistakenly measure y in centimeter shorter from the correct measure marking, right? Now, hence, all the distance measured were y centimeter shorter than what it is supposed to be, right? Altogether, right? So they are saying the official there that were measuring the distance of the long jump athletes, they made a mistake. Basically, they measured distance y, which is shorter from the correct which means probably they might have moved whatever measuring tape that they were supposed to use a little bit much more further than what they were supposed to start, right? I think here that's what they are showing us in here. Now, what is that you're having here? They say, hey, they say the correct mark from where the distance should have been marked it's A. So then they were supposed to start at A, but the incorrect mark, which means what they did is that they started at B. But luckily, all the distance or all the athletes who were doing the long jump, they were measured from B and not from what? And not from A, right? Then they are saying the C is the mark to where the distance was measured, right? So basically, this is the end point in which this was measured. Right now, I want you not to stress here. Remember, this is probably given in terms of pattern. Now, they say where the correct, when the correct correlation is made in distance, the sum of the athletes with the best jump is now 5 centimeters. In other words, it is given by 11. The sum of the 11 term is given by what? 5555, right? Which is 5055. Okay. So what is this then means, right? So which means now from here to find out what will be the new average, right? To find out what is going to be the value of UI, to find out what is going to be the new average, it is simple, right? So it's either we can do it this way, right? It's either we can say from here we are saying our new average here will be what? Our new average here, it's going to be what? Remember here they use K, right? So average of K, it's going to be 5555 divided by 11, right? And what are you getting here? You are getting your average of K, which is going to be 550 altogether, right? Right now, to find out the value of Y, remember this is not where, this is not the Y, but this gives you what? This gives you the average of the distance, right? Now we know that average is going to be what? Now in this case, the average is going to be average subtracts the mean, right? Which is the previous mean. Okay, to find out now what is, remember this is the new mean, right? This is the new mean, right? That is new. And then this is the old mean altogether, right? So which means here this is going to be same as 505 subtract what? 505 subtract 4. I think the previous mean was 498 altogether. And now to find out then the value of your Y, I think the value of your Y that you're going to find out, which means they have, they have mistakenly did not count 7 centimeters of all the athletes altogether, right? So they haven't calculated the what? They haven't calculated the 7 centimeters of all the athletes. So basically, now that's what they haven't done in there, right? So now from here, they are saying now they want us to write down the standard deviation of the new correct distances, right? Now of the new correct distances. Now I want you to take note here. Remember when we are looking at your standard deviation here, right? Remember our standard deviation, yes, we know that it is also measures our central tendencies, but now there are certain things whereby in which your standard deviation cannot affect altogether, right? So now, for example, if you can look at this particular data, right? Now, from this particular data, I think you can be in a position to identify that all the distance were mistaken, right? Altogether, it's not only few distance or few athletes, but it's all the what? It's all the distances, right? And if it's all the distances that were affected in this particular case, our what? Our standard deviation is not going to be affected, right? uh, our standard deviation is not going to be affected. And why am I saying that, right? Remember, if we are looking at what is standard deviation, right? So basically, standard deviation, it measures how spread out the set of values are. Altogether, right? It is measuring how spread out the datas are altogether. And now it can only measure, right? It can only measure looking at what? Looking at the number of the data, looking at also the data, and looking at also the mean altogether, right? So, and in this case, there's nothing that is going to be affected in terms of what? In terms of the mean, because the spreadness of the data is not affected, right? Now, when we are looking at the spreadness, we are looking at whether the data, if it was skewed to the left, it will continue to be skewed to the right, to the left, or rather, if it was skewed to the right, it will continue to be skewed to the right, because there is no new value that was added there besides the fact that only the initial distance that was mistaken, right? So which means therefore here our standard deviation will remain the same way as it is. It's going to what? It's going to be still, what was it? It's going to be still 119,47, right? What can affect the standard deviation if there was a change in Q1 and maybe your Q3, right? Now everything then was going to affect it. Are we together, right? So basically, this is how we go about whenever we are required to do these particular questions, right? Hopefully, all of this makes sense.